Thank you. Yeah, so click on that. Thank you, Maria, for inviting me. Thank you all. First of all, thanks to all of you that got in touch with me with certain issues with your licenses, desktop licenses, MATLAB online licenses. I hope that all worked out for you. I've looked at the activations of the licenses, so I think you guys are good to go. A little bit before I start off, just a short background about me. I am a neuroscientist by background, so I'm not a biologist. I know nothing about metabolomics or fluxomics for that matter. And I was in academia like you for a very long time as a graduate student in the States, and then as a postdoc and a junior PI in Germany. And I was programming quite a bit with MATLAB. I was doing a lot of signal processing, a lot of image processing. And I don't have a background in computer programming and engineering. So I learned MATLAB by doing things, right? So, and referring to the all-powerful help. So I think things have become a lot better now over the years with the releases. I encourage you to look at the help functions and also MATLAB answers. So this is a community where sometimes people who work at MathWorks answer questions and others in the community answer questions. Actually quite useful, specifically if you have like niche questions about a specific area. So after my academic career, I joined MathWorks. My role at MathWorks is I work with science gateways, which are things like ELIXIR. So people at MathWorks also ask me, what are science gateways? And essentially they are portals or organizations that share resources with scientists like ELIXIR. And I try to help people who are using MATLAB as part of these portals to get the best experience. And as many of these portals also have to do with open science and sometimes open source, I also talk to a lot of people who talk about how important open science is these days and what people can do to make their MATLAB code open. And these are a lot of the things that I'm involved in. So without further ado, my presentation today has the following expectations. After this, you should feel able to navigate the MATLAB environment and code some simple things, which I think you should already be up and running, because I've seen the slides that Maria shared this morning about optimizations and matrix multiplication, etc. You should be able to search through MATLAB help and find your way around. Then you should be aware of certain possibilities of speeding up your code. So certain good coding practices, which we all start off scripting, and then at some point we really code, which means we all just start writing things on the command line, and at some point we start making programs that others can use. And then I want you to be aware of some specific features, such as making apps and making graphical user interfaces, what we call GUIs, and live scripts, which are essentially notebook style scripts in MATLAB. So I've organized this talk in 3 different sections called writing code, writing good code, and writing open code. So writing code is all about very basic. If you've never opened MATLAB before and you don't know what to do, then introduces you to what MATLAB is, talks about the different data types, scripts, functions, loops, plotting basics. Then writing good code is about speeding up your code, about apps and graphical user interfaces. I'm not going to touch a MATLAB profiler today because this is a product that is not included in maybe all license offerings. You might have it, you might not have it. And then I'm going to talk briefly about object-oriented programming, because part of what Maria said, optimization, there is an optimization toolbox and there is an optimization object which you can actually use to optimize a function. So I'm going to make you aware of what an object is and how you can interact with that. And then finally, I'm going to talk about writing open code. So how you can share your code with people, use file exchange, which is sort of the MathWorks hosted free community platform for exchanging code, using MATLAB with other languages such as Python, and also creating MATLAB code that others can reproduce, right? Because not everybody has a MATLAB license, as you know. Okay, So let's start off with writing code in MATLAB. So MATLAB is a higher level programming language, which means you write something that makes sense to you because you can read the number 10 and 5 and the symbol plus. And as you execute your code, then each line is compiled into machine language, which is then executed on the CPU of your machine. And that enables the computer to do that particular computation and give you an answer, right? Now, this compiler that MATLAB uses is called a JIT compiler or a just-in-time compiler. So if any of you have programmed in C, you know that there are languages where you write your code and then you compile it in one go, and then it's a compiled code in machine language which is executed. And the way MATLAB works is that each line is executed as you go along. So that's why it's readable, and that's why it's a higher level higher level programming language, because it translates machine language in something that you can understand. The name comes from matrix laboratory. As you can imagine, MATLAB is particularly well suited in matrix operations, linear algebra, vectorized operations, etc. You can perform numerical computations. There are about more than 100 toolboxes for various users, including bioinformatics, statistics, signal processing, optimization, etc. And it ships with an IDE, which is an integrated development environment, which is essentially what you see when you open MATLAB. You see this window that helps you put the different icons and pull up your variables. That's an IDE. And it is essentially a programming language environment that is built for scientists and engineers. So unlike Excel, which is very, very sort of basic, this is geared to a scientific audience. Your MATLAB environment for the workshop, you should have had a MATLAB online license and a MATLAB desktop license. And most of the things you should be able to do with the online version, which is the MATLAB IDE via the browser, but you have a desktop version as well, in case some of the things you want to try out offline. Your MATLAB licenses will remain valid till the 25th of October, following which they will lapse. Okay. So this is the MATLAB IDE. In the middle, you have your editor or your live editor, depending on if you're writing scripts or live scripts, which I'll come to later. But essentially, it's where you script, where you write your code. On the left-hand side, you see the folder view, where you see the folders that you are looking at, your current home. Setting paths is an important part when you start off MATLAB. You must set the path so that the program knows where to look, and the folder with your code that you want to execute should be in the path of MATLAB. You can do this using the command add path. Bottom left, you see your workspace, which are the different variables that you're working with. Sometimes you might want to save your whole workspace just using the command save, saves all the variables in your workspace in a mat file. But that's not a great idea, because you should actually save particular variables that contain values that you want to use the next time. So saving workspaces is not the best programmatic concept, but you can do it if you want. If you click on one of the variables in your workspace, the variable editor opens up where you can see what is inside that variable. So in the matrix, what the rows look like. And at the bottom, you see the command window. The command window, unlike the editor, you type in a command, and when you hit enter, it executes. Okay. On top here, you see the MATLAB drive. MATLAB drive is basically a cloud data space with 5 gigabytes of space. This comes with your MATLAB online license. And if you get the MATLAB drive connector, which I talked about, you will have a folder on your Windows or your Linux desktop, which you can sync with the MATLAB drive, so you can move files back and forth. Right, so that's what the MATLAB drive icon looks like on your Windows taskbar. MATLAB help, this is really a lifesaver. So there are many ways to look at help functions when you don't know what to how the syntax is or the input arguments. You can either type it in the document search documentations window in your MATLAB online or desktop IDE, or you can type in the command doc, and then a particular function if you know which function you want to use. And essentially that brings up this documentation page. If you look at this on top, you find the name of the function. You see the syntax, so different ways you can call the function. You also see 3 tabs, so it shows you examples and functions. And examples is actually a nice place where you have actual examples using this function, so you can see the different ways it's used. If you open the help function, you'll also see this thing called Open Live Script. What that does, it opens up that particular example in MATLAB Online, so you can run it and see how it's behaving, or you can change parameters and see what goes wrong. In terms of more training for MATLAB, you have the on-ramps. So we offer the on-ramps, which are free of charge. You don't need a license for this. You just need a MathWorks account, which all of you should have now. Many of you've done, I assume, or all of you've done the MATLAB on-ramp, which is a very basic introduction to the language. The optimization on-ramp can also be interesting for a few of you. Shows you how to do optimization problems with MATLAB. And if you're interested, there are other on-ramps as well, like signal processing, deep learning, etc. Apart from that, there are also programming courses that you can access here that are paid. These are included in campus-wide licenses. So you should, if you're interested, you should find out from your school if this is included in your school's license. Okay, so that was background of MATLAB. I'm going to start now talking about the second thing on the agenda in that first writing code. And these are data types in MATLAB. So we've got a bunch of different ways you can save data, which depends on the nature of the data. And these are called data types. Now, in the beginning, the joke was that MATLAB is all double. Double refers to double precision kind of data type. These are for numeric data. So in the very beginning, one had numeric data. You can save it either as double precision or single precision data types, or logical. Logicals are basically an array of ones or zeros, which are true or false, depending on a condition, right? You can also use heterogeneous data types, such as structures or cells, in which you can save different types of data. So you can save numeric data and string data in the same structure or a cell. Cells are denoted by curly brackets. That's how you also type in the cell. You construct a cell in the MATLAB command window. Structures have different fields, and in these fields you can pack different variables, and the field of a structure can be a cell as well as an array. For text, for the longest time we had characters, where you have a text and each character is a single indexable data type. So I should actually open my MATLAB desktop and show you what I mean. So this is just cleaning my screen. So if you want to have an array, this is how you create an array. You saw this morning with Maria. If you want to have a cell, you can create a cell. You can put in, let's put in a character. You can put in a character, and you can also put in something else like a number. So a cell is a mixed sort of heterogeneous data type. Structures are, so you can have, say we call a structure, and you can have fields. So you say field 1 can be a numeric, and field 2 can be a string, and then this would be what the fields look like, right? So you have a structure and you can save different values in the field. So this could be a recording file, for example, and the fields could be different channels, for example. Okay, let's go back. Then in 2013, we had a couple of new types of data types, categoricals. Categoricals are I'll come to this later, but it's like if you have a defined set of values this variable can take. So for example, say you have 3 types of experiments, of conditions: experimental, control, and test. And the value can be one of these 3. Then you can save it as a categorical array, and it's easier to save in terms of memory, and it has indexing enabled, which I'll touch in a minute. And tables. tables are very good for tabular data when you're reading in CSV files, Excel files. Then tables allow you to do a lot of operations on this kind of data. Then we've got some temporal data, so date times. You can easily save times, so of dates, as a particular date time object, which preserves the timestamps if you're working with time arrays. And then also we have things like timetables, which is basically a combination of table and time strings. And then in 2016 we also had the string arrays. So strings are, if you look at characters, then characters are denoted by single quotation marks. So this would be a character, right? So let's call this CH. And a string is denoted by quote marks. So this would be a string. Now, what happens is if you take characters, then you can index into each of element in that character array. And what I mean by that is, so CH is character. I can say, give me CH2, and that will be H, right? So the word is kept as a combination of its characters. Strings, on the other hand, if I ask for, it'll be the whole string. And what one can do very easily with strings, one can add strings, and I'll talk about this in the next slide. So I can say string, and I can add another string, and then I'll have this. Okay. All right. So those are the basic data types. A little bit more about strings. So these are really for text data. They have the string arrays have improved execution speed now and memory usage versus cell string, which is sort of what one used to do back in the day when we didn't have these string objects. So here are some of the things you can do with strings in terms of manipulating, comparing, and storing text data. The first example you see, I've taken image as a string, and I have .png as another string, and I want to create names of files, so images, right? So I just have a vector 1 to 3, and I just add those, and basically MATLAB converts every one of those numeric objects, numeric data, so 1, 2, and 3, into strings and puts them together. So you have image1.png, image2.png, image3.png. What you can also do is you can use the command contains if you want to see if a certain string contains this pattern, dog, for example. You can also search for certain string patterns within a bigger string. So this is, for example, if you want to, if you're talking about sequences, etc., this might be interesting. You can generate a random search pattern by using this command digits pattern. There's something similar for text. And what I've done here is I've created a pattern with the string R, the string A or B, and then digits pattern simply means 4 digits in a row. Yeah. And then I have a string here. String was introduced in 2016 B, pattern was added in 2020 B, and I want to extract the string that matches this condition in the pattern PAT. And extract that from the string. And then it goes ahead and extracts R2016B and R2020B because I'm asking it to give me a pattern that starts with a capital R, has 4 digits, and ends in either small a or small b. So you can quite nicely look for patterns in larger strings. Tables. Tables are good for mixed type tabular data. So if you have data that makes sense in sort of a tabular format from CSV files or Excel files, you can include metadata. You can, each of these column names are called variables. So you can actually create a table and you can access the properties of that table. And in one of the properties will be variable names. And then you can set the variable names. You can also set row names, and you can index the table in different ways. So you can either say table dot, so you could, if this table was called data, say, you could say data dot state and get the list of the state names. This is a little bit like the way you would work with structures, but you can also index into it like you would do with a matrix. So you could say data 1, 2, and that would bring up Kentucky because it's the first row and the second column, right? And you can do things like you can join tables like stack or unstack tables pretty easily. Categorical arrays, this I briefly touched upon. Categorical arrays are good for discrete non-numeric data that is drawn from a finite set of possible values. So my previous example, control and test, for example. With categorical data, so here's the same table and you see event type is categorical. It can have one of several values. You can actually sort them pretty nicely, and you can look at them in a graphical user interface kind of view. It has you can order them. So for example, if you have category names that can be ordered like good, okay, poor, things like this, you can order them. You can also protect your categorical array so that people don't add new category names to that array by mistake. What categorical arrays also are good for, they're very good for, they're a better way of saving memory when you're working with large strings. So here's an example. Here I have a string array. So string, that's why it's in double quotation marks. And I have test control, test control. I have basically two values here. And so I have saved this as a string array. And in the second line, I have converted this into a categorical array. So now if I use the whos command, WHOS, you can look at the parameters of a variable, right? So if I use whos string, then I look at the size in terms of memory of this variable, and I can do the same for the categorical array. And you see that the categorical array is requiring about half the space of the string array. And this is because the string array has to save each of those strings, and the categorical array only saves the two strings, test and control, and then basically a logical indexing array, right? So it'll just put ones and twos in a numeric array, and one corresponds to test and two to control. So that's a much more efficient way of saving this information. Okay. To move into scripts and functions. If you go to your MATLAB IDE on the top left, you click on new, you can open a new script or a function or a live script. And what are these? Scripts are saved as M files, .m files, and a script is basically you put a bunch of different commands, and they will be executed in that order when you click on the run button on your MATLAB IDE. So this is a script that generates a simple sine wave. So I've put in some default parameters for frequency, amplitude, and the phase shift phi, and then I use a time axis, and I'm computing a sine wave. The thing about scripts is it runs with those variables that you encode in that script, right? Which means if you want to run this with a different parameter value, so if you want to run this with frequency of 10, you have to actually go into the script and delete the 20 and write a 10 and rerun the script. It has a shared workspace with your main workspace, which means if I open my MATLAB workspace and I open a script and I run it, all of the variables that the script uses or creates will be available in my main workspace. And as I said, you have to change the values to rerun them. If you're running a certain analysis again and again and again, then a good way to package that is using a function. Functions are also saved as .m files. But when you create a function, instead of just starting to write your script, you need to have this syntax on top that says function. And then in those square brackets, you write the number of outputs that you expect this function to provide. And then you give the function a name. In this case, I've called it sine function. And you pass certain arguments into this function as input values. And you can actually, using the arguments syntax, and I've shown you how to do this here, you can validate the input argument so that people cannot, for example, enter a string for a value for a frequency. And you use the arguments block, and then for each of these input variables, in this case, f, a, and phi, you can specify certain constraints. So for example, let me move this here. Okay. So before I go into the constraints, let me just say that the nice thing about functions is it can run with user-defined variables, which means unlike the previous script, where you had to go in and change the frequency value, the user can now call this function with different values for f, a, and phi, right? The workspace of a function is separate from your own workspace. So if you have a function and you run it and you stop in the middle of the function, then you will not see the main workspace. You will only see the variables in that function. And when you go back to the main workspace, you will only see the variables that this function outputs. So I probably should, at this point, go back to MATLAB and give you an example. Okay, so I'm gonna go to home. I'm going to create a new script. I'm going to call this function y simple function x. And then I'll just create a variable here, and then I'll basically output what you inputted. Yeah, so this is a very, very simple function. I'm gonna go here to a place where I wanna save this. Okay, so I'm gonna save this as simple function. Okay, so I can now call simple function with a string. And the output will be the same because inside the function, the x has just been moved to y. Now, if you look at my workspace here, you see I see the output of the function, but I don't see this variable a within the function, right? If I stop the execution within this function, and you can do that by setting breakpoints. So you can click on one of these each line, and when you set a breakpoint, what happens is the code execution stops at that point, so you can debug. You can see what's happening at each point in case you have an error. If I do this and I again call simple function, now we are inside the function, and you notice over here we don't see the main workspace anymore, right? And you can continue going line by line of this function. So I execute this, then I see A, then I execute Y, and then if I click on this, if I step out of the function, then I'm back in my main workspace again. So it's like a nested workspace where you go in once you enter the function, you are in that ecosystem, you work in your function, and then you come back again in the main workspace. So, okay. A little bit more about how you can define arguments that you pass into the function. This is the arguments block that I was talking about. You can constrain the size of the input. So f has to be, frequency has to be a scalar. It cannot be a vector. It has to be a double data type. And it has to be numeric. So you cannot enter 1 as a string into this function, then it'll give you an error. And the default value will be 20. So you can call this function without any of the input values, and in that case, this will automatically generate the output using these default values. So this is a good way of checking that the user is indeed passing in inputs that make sense within that function. Okay. These are a list of different function argument validators that you can use in the arguments block. Then we have a different sort of script, which we call live scripts. And live scripts are basically executable notebooks, the same way you're probably familiar with Python notebooks, where you can combine text and rich text and formula and code and output all in one document. You can divide in the live text. You can divide the body of the script into sections. If you look on your IDE, you will see section break, and you can insert section breaks, and you can run one section at a time. You can embed the outputs next to the code. You can add, as I said, rich text formatting, things like equations, images, hyperlinks. You can also include animations. So this is an example where we have plotted something, and that gets saved as an animation. And not all plots get saved as an animation. There are certain commands you need to use to create animations. Comment is one of them. And if you export this, then the animation will actually be exported as a GIF starting from 2021B, which is the current version. You can control fonts of your output. And what is nice is if somebody doesn't have MATLAB, and if you want to share your script with them, that they can understand and read it and understand what is going on in the script, you can export a live script in various formats such as PDF, HTML, LaTeX, Word, that is readable without MATLAB, because the .mlx format. So unlike the .ms, which are normal scripts, live scripts come with the extension .mlx, and the .mlx format you need MATLAB to read. So essentially this is an executable notebook. What is also quite nice, I think, in live scripts is you can add interactive controls. And I think this is somewhere where live scripts are actually quite easier to use than Jupyter notebooks, because in Jupyter notebooks one has to implement IPy widgets or these libraries, and in live scripts you can go and just simply insert certain live user controls like sliders, drop-down boxes, check boxes, and you can also hide the code. So when the user interacts with your code, they have certain interactive controls like sliders, and they can set parameters, and then your code runs. You can also link variables to your user UI controls. So for example, I want to create a drop-down menu and I want to have a bunch of surnames. So I can save the surnames in a variable called last names. And there I have saved it as a string array, and I can simply link that variable to this user control, so that when you look at the user control, when the user looks at the user control, they will see a list that is populated automatically from this variable. Okay. You can also generate code from live tasks. Live tasks are, if you go on the panel of your IDE and under the live editor tab, you will find a little icon. So here called task, and you can insert certain live tasks in your live script. Live tasks are basically standardized computations. For example, plotting or cleaning data or smoothing data or averaging. And essentially you can point to different variables in your workspace for to pass into this live task, and then it creates that. So here's an example. We have some data. I say clean missing data. I select the variable that contains my data, and then I ask it to clean to fill the missing data using a moving median, and then it automatically does that. And if you go here and you click on code only, then you will. So this is controls and code. If you click on code only, then you will actually see the code that was generated when you were clicking and pointing at the GUI, right? These are some new live tasks that we have included in 21B. Each release sort of comes with a lot of development in terms of live tasks. I'll go now to the MATLAB online environment, and I wanted to quickly show you an example. So I'm going to go to my MATLAB drive. I'm going to go to my folder. And again, I will show you a very quick example. So here I just created a MLX file, which is a live script. I'm going to use, I can toggle between text and code. So this is text. I can now type in text. And if I want to type in code, I can click on code and have a code cell. I'm going to give this thing a name. I'm going to select title here and call it simple sine. following which I will put in a block of code. Again, I will use a simple sine wave. I'll have a frequency. I'll have a amplitude. Now I will create a time axis. And I will create a sine function. So amplitude times sine of 2 pi times the frequency times t. And now I am going to plot this. So I'm going to say plot t against y. So I can execute this by running this section. Oops, I used a small variable. Small, this should be capital, or I can change this to small. I'm going to make this a little bit bigger. That is more readable through Zoom. Okay, so.
And F, no?
Go ahead.
That F is defined? Ah, yeah, at the beginning, yeah.
Yeah, F is that, yeah. So you see, this is my output. I can have it inline, or I can have it on the side. Now, what I'm going to do, suppose this is a program that I've written. I want to make F, the frequency, tunable, a tunable parameter that the user can change, right? So what I can do is I can select this and I can replace this with a live control, in this case, a numeric slider. If I double click on this numeric slider, I can either add, so I can give it a default value. I can give it a minimum and a maximum value. So I'm going to give this a maximum value of, say, 50, and each step is 1. So if I do this now, the user can change this, and you will see that the plot changes as the user does that. So you can, if you have an algorithm, then you can make certain parameters tunable for the user to use. What you can also do with live tasks that I was talking about, going in here in the task window, you have a bunch of different live tasks that you can use. Starting with this release, you have create plot, which I think is quite nice, because essentially, and I will touch base upon, I will show you this more on a later slide. You can choose what kind of visualization you want, because you don't know all of the types of visualization that MATLAB has, and you can select your data and you can ask it to plot. But I will show you something else here, actually. For example, for data pre-processing, I want to find the local maxima and minima of the sine wave, right? So what I do is I go here and I insert find local extrema, and that's a live task. And now I can select the input data for this live task, and I will select the variable y, because this is my sine wave. And I can choose, so you see it's showing me the maxima. I want to see the maxima and minima. And when I do that, then the plot updates. What is nice with these live tasks is you can click on these 3 buttons here and look at code only, and you look at the code that is generated when you were doing this clicking, right? So you can also convert this. You can convert this task to editable code. So now I've converted it to editable code. So you have a starting point, and then of course you can go in here and play with the different parameters for plotting. This is often nice if you don't know all of the different ways you can interact with the plot, to get a first in and then play with the different parameters. Okay, so that was about scripts, functions, live scripts, loops and conditional statements. I think most of you are familiar with this, so I will not dwell on this for a long time. But in programming, sometimes you have to do something in a loop as you go through a variable. You have the for loop. This is the syntax in MATLAB. For I equals 1 to 3 in this example. The first line, this is the loop counter. This will run till the variable I reaches a value of 3, and then it will execute the body of that loop. You can also have while loops. So you can put in a condition. Here the condition is that the variable has to be less than 10, and as long as that condition is satisfied, the loop executes. You have to be careful that you have a condition that will at some point not be true anymore, otherwise you'll have an infinite loop, right? So I'm incrementing the variable here within the loop, so whenever on the 11th run of this, depending on the initial value of the variable, on the 11th run of this, exit the loop because I will be more than 10 or will be 10. Then you have if conditional statements, so you can have some conditions, so you can comparisons, and if that condition is met, certain things happen. And using the else statement, you can say if that condition is not met, then certain other things happen. You can also use the switch case statement, which is you have a variable, in this case choice, and it can have 2 possible values or 3 possible values, and you say if in case of the value matches this particular case, I'll execute this bit of code, and if not, then I'll execute this bit of code. A lot of it is for a lot of problems, as you can see, you can use the if else loop or the switch case loop, right? Now moving on to plotting and data visualization, MATLAB really offers you a huge variety of different plots. This is also an area where we're actively developing. So every new release, you have quite a number of different plots come up. This is a overview of all the different plots that are possible, 2-dimensional, 3-dimensional, etc. I'm not going to go into all of them. But what I'm going to say is there is a message. Yeah, that's a typo. Thanks for catching that. I was thinking C, and I was writing MATLAB code. It should be II+1. I briefly mentioned this live task to you, the create plot live task. I think it's quite useful to have an overview of what kind of plots might fit, and then you can take it from there. You can generate the code for the basic plot, and then start adding to it. Here's a video to show you an example. So here you want to make a scatter plot. You select 2 different variables, and it plots that. You can then change the characteristics of that plot. So you can change the marker, you can change the color, things like this. And you can then go and add another plot on top of that. So here we're adding a second plot, and again a scatter plot with 2 different kinds of 2 other variables, and you see the 2 different kinds of scatter plots are shown on the same window. Programmatically, you would do this using hold on and hold off. Okay. These are some of the newer charts and visualizations that have been added. I find the swarm chart particularly nice. The swarm chart is used when you have a lot of values that have the same that have the same value on the x-axis. And if you can imagine, if you plot a bunch of different y's for the same x on the x-axis, then they will all overlap on each other. And if you plot it using swarm chart, then what it does is it jitters the x a little bit, so you can see the distribution of the data, the distribution of the y's for that particular x. Okay. All right. So then we come to importing data. You can import a bunch of data into MATLAB. You can use the import data tool. This is one of the things that you will find in your MATLAB toolbar. You can, when you're importing the data, it automatically recognizes the format and can give you suggestions. For example, for CSV files, it can ask, it will automatically suggest the table format. You can choose what to do directly with the missing data. If you want to interpolate it, if you want to fill it with nuns or blanks or zeros, things like this. Little more about reading and writing different kinds of data. So back in the day, we used to have differently named functions for different data types. Now there's a certain logic for reading in data and writing data. So if you want to access data, you have these different kinds of read-in functions that start with a name and then ends in read. So that's what the asterisk read here signifies. Yeah. And these are basically telling MATLAB to read from a particular data source. So IM_read means image read. So that's going to read from a particular image, particular type of file. So image files, PNGs, TIFFs, that kind of thing. FASTA read, this is in bioinformatics toolbox, FASTA sequences, CDS for CDF files, etc. You also have the same logic when you go to the write part of it, right? So you can have different functions ending in write, and that would tell MATLAB to write the data to a particular kind of format. So it could be an image write or a FASTA write or a CDF write, just analogous. And there's a bunch of others. On the other hand, you also have functions that start with read. So read asterisk, and that's telling MATLAB to read the data into a particular sort of data type. So it can be read table, read cell, read matrix, read structure, etc. And similarly, on the right side, it could be when you have things starting with write. So write table, write timetable, that would write into a certain type of data type or format. So if you want to create a CSV file, you would say write table, put in the variable, and give it the extension CSV. We also have these things called data stores. These are helpful when working with large amounts of data. So a data store has the format asterisk and then data store. You have tabular text data stores for tabular data. You have spreadsheet data stores for spreadsheet data. You have file data stores, image data stores. What the data store does is maybe those of you who might know this in other languages are essentially like data pointers. What the data store does is if you have a large section of Excel spreadsheets, say like 500 Excel spreadsheet, you can point the data store. You can create a data store variable and point it to the folder that has these 200 Excel spreadsheets. And the data store is going to take the names of those spreadsheets and scan them and give you a data store object, which is far less in terms of total memory than reading in all of those different files. And then you can extract the data that you want for a particular analysis from that data store. So the data store is sort of like a handle to a large database, and you only load what you need. So you can load file by file, or you can read a certain snippet from that data store. Yeah. Or you can also do read all, where you just load the whole data store into your memory. Good. So that was some basics about how you program with MATLAB, how you work with the different MATLAB data types, and some basics of programming. Now I'll go through some examples of how to write good code, and I'm going to talk about speeding up your code, MATLAB profile. I'm not going to talk about today app designers and object-oriented programming. So let's start with speeding up your code. There are several things that you can do to make your MATLAB code go faster. Let's start with the first, installing the latest release. So this is a graph showing you the average speed up in workflows that has been that we've achieved with subsequent releases from 2015A. And you can see that there's actually quite a lot of effort spent with improving the bottlenecks for faster execution of code, and especially faster execution and indexing of certain data types. So if you have the latest version of MATLAB, you're always getting the optimal version in terms of speed. Then there are a few tricks that are good programming practices that you can employ to make your code more to speed up your code, make it faster. The first one is called pre-allocating memory. Pre-allocating memory essentially means pre-assigning a certain block of your computer's memory by initializing arrays to their final size. What do I mean by this? I'll give you an example. This is an example of a code that I'm doing without pre-allocating, okay? So tick and tock are timers. So you can put this around any piece of code, and basically tick starts the timer and tock ends the timer, and you can put like a variable in front of tock, and it will give you the total time of execution in seconds. Good. So here I have a loop, and I'm looping across a huge loop for t, and I'm creating a sign. I'm creating the sign function of each t. But I have my initial variable y, which I have initialized using just a 0. And every time I go into this loop, I'm adding to that y variable, and I'm adding the sign function of the current t to that y variable, right? So essentially what MATLAB is doing at every step is it's taking y in its current form, it's duplicating it, it's making it bigger by one space, it's adding the new thing, it's getting rid of the previous one, and it's re-entering the loop. Now, obviously, if you do this by pre-allocating, and in this case, in this line, y equals zeros, I have basically made y an array that is the same size as the total loop length, then you can just then you do not have to do this doubling of the variable every time, and it will be a much faster operation. So in this case, you have a speed up factor about 4.5 times. Yeah, so you can look at the tick and talks. The next thing that you can do is vectorize your code. So vectorizing always helps. What do I mean by vectorizing? When you have your code and whenever you have a loop that you go through, you should always think if there is a way to convert this loop to a vector or a matrix operation. You saw how matrix operation work with this morning with Maria's lecture with the different coefficients of linear equations. I'll give you a very stupid example. Yeah. So again, my TikTok example, I have here, instead of looping like I showed you before, now I'm just going to say y equals sine t. And because MATLAB is a matrix and vector-based language, what it's going to do is it's going to take automatically the sine function of each of those values in t. And then I don't have to go through a loop. And I've been able to speed up my code by a factor of 11. When you do vector operations, when you want to do something with a vector, one thing to keep in mind is the dot notation. And what do I mean by the dot notation? I can give an example. So I'm going to clear my variables here. I'm going to clear my screen. So imagine you have a vector, right? And this is a vector. Imagine you have another vector. And this is going to be a vector that is not a row vector, but a column vector. Okay. That's why I'm putting the semicolons. And so now MATLAB being a matrix-based language, when you say A times B, right, it does a matrix multiplication, which is A. So this times this plus this times this. You know how matrix multiplications work, right? So if you do A times B, you will get this. And this is what happens if you multiply the matrices A and B. But if you had initially wanted actually to multiply each element of A with each element of B, then first of all, you'll have to convert B into a row vector. And then you have to use the dot notation, which is A dot multiplication B transpose. And the dot notation basically takes the whatever you specify here and applies it to each element of that vector. So for example, if I want to take the power of A, then I need to put the dot and then the power and then the notation, and then it will give me the power of every single element of A. Yeah. Okay, so that was dot notation, vectorization. The last thing I'm going to talk about in terms of speeding up your code is logical indexing. Now, in MATLAB, you have these logical operations. Logical operations are those that that use these sort of conditional statements, and you can use something without a logical operation using a loop. So here I'm going through a loop and I'm testing if the variable y has the word test or not, or control, and I'm changing that. And using logical indexing, I can just say y1 and put my condition there and put it in the index, so within brackets, and it's basically going to apply that condition, and every cell or every member of that array that satisfies that condition will be extracted out. So you don't have to go through a for loop. And again, you have a huge speed up when you do logical indexing instead of for loops. Then you have apps. We already spoke about these live tasks, but you can also have apps. This is App Designer. So if you go here to Home, Apps, you can design app. And here you can have a blank app. And then you have this app, and then you can put in different things here, right? So you can put in a plotting window, you can put in a push button, and as you're designing this, you can click on code view, and on the back end of this, MATLAB will spit out code that you can then program, which will happen when a user interacts with these elements. So for example, when a user pushes this button, what happens? So if you go here, then you will have a button callback. There should be you have to add it. So you see here callbacks, and you can say I want to add a callback, and this function is going to be executed when the user clicks the button, and then you can say what happens, right? So I will show you here. So yeah, so you've got standard components, you've got different other components, and you have properties and methods that come with these different components, and you can program those to execute so that the user has a nice GUI that they interact with. What you can do with apps, you can give it to someone else as a MATLAB app, which they can use if they have a MATLAB license. You can package that app to be an installation file that people can install. You can also, if you're licensed for MATLAB compiler, you can convert that app into a standalone executable, which you can give to anyone using a .exe file, for which they don't have to have MATLAB to use it. Yeah. You can also have, if you're licensed again to use this thing called MATLAB Web App Server, you can host that app on your own server, and other users can access that via the internet, so they can access your app. So these are all if you're thinking of going in and have others use your apps. I'm going to give you a briefly touch on object-oriented programming. Object-oriented programming is very strong in other languages. MATLAB, you can also use object-oriented programming. Basically, this follows the idea of creating classes of objects. And a class is a blueprint for creating objects. It comes with its own properties and its own methods. So for example, say an object is an instance of a class. This doesn't make any sense to you, but let me give you an example. So if you have a class dog, yeah, so this dog can have any dog can have properties such as a breed, an age, a color, and it can have methods of things it can do. It can bark and eat and sit, right? You can't do that if you have a car. A car cannot have a breed and can have an age and a color, but cannot have a breed and cannot eat, sit, and bark. So for a car, you have to create another class, which is a class car. And this class dog can have different instances. So both of these are dogs. They have different values for those properties, and they can use those methods. Now, this is an abstract example. What you can do, and now I'm going to give you an example that makes a little bit more sense. Optimization. You can create an optimization problem in MATLAB for a particular optimization problem that you're trying to solve. So you use the function optim problem, and then you can give it a description, and let's just call it example. Now, if you do that, this is a class. This is a particular class called optimization problem class, and you've created an instance of that class. And this class comes with certain properties. So it comes with a description, it comes with an objective sense, variables, objective, and constraints. And essentially, you can pass into this into this optimization problem variables for your equation that you want to optimize. You can give it an objective sense. So do you want to maximize the function or minimize the function? You can put in constraints. And then you can, if you take this, and let me just put it in a variable called problem. If you, oops, what happened? There you go. So if I look at properties, you already saw the properties. Let's look at methods. If you look at methods of problem, it's a little bit slow, my internet. So you see that there are certain methods called solve and show, right? And solve is basically once you've loaded this optimization problem with your equation, with your variables, with whether it has to be minimized or maximized, you can just say solve this optimization problem with these starting variables, with these starting values, for example, and then it will automatically choose a solver and solve it and give you the output. So this is an example of a class when you interact with the class, and this is an example of object-oriented programming. Okay, so I think I'm up on my hour. This bit is the easy bit. So if you want to write code with MATLAB, we are a proprietary software, which means we're not open source, but we're trying to have it so that users can actually exchange their code and use their code interactively with others. And here's a couple of examples of what we're trying to do. If you have ideas or examples or requirements, please get in touch with me. So MATLAB File Exchange is hosted by us. You can upload your tools if you have tools that you want to share with the community on MATLAB File Exchange. You can also go there and search by discipline. So under biology, you have different kinds of user uploaded open source community toolboxes. The Cobra toolbox is one of these. It will be used on day 4 by Ronan Fleming to do some exercises with you. You'll notice here view license on GitHub and download. So if you this is actually a GitHub repository that's been linked to File Exchange. From MATLAB IDE, you can also use the add-ons button to install a community toolbox from File Exchange. If you are a toolbox author, you can just simply link your GitHub repository to File Exchange, and every time you have a new release on GitHub, File Exchange will update it automatically. So you don't have to do anything more. But the MATLAB community hangs out at the MATLAB File Exchange, and they might look at your tool, might get more visibility. In terms of connecting with non-MATLAB users, there are free MATLAB trials. I've talked about MATLAB web apps. One thing I want to make sure to share with you is we have this thing called third-party access for academia, which means if you have an academic license and you have a collaborator who does not have a MATLAB license, you can share your academic license with that collaborator for free without asking us. The only condition is that the MATLAB access needs to happen on your hardware. So imagine if Maria University has access to a campus-wide license and she wants to host the course, or she wants to have a community and she wants to give them access to MATLAB for a project, she can do that by just opening her MATLAB license and allowing you to add on to that license as long as the MATLAB happens on her hardware. And I also wanted to briefly mention, I won't go into this in detail, you can call MATLAB and you can call MATLAB from other languages and other languages from MATLAB, specifically Python. You need to install something called the MATLAB engine on the Python side, and then PyEnv. Denise talked about this slightly. You can call Python functions from MATLAB, and you can call MATLAB functions from Python. And there are, if you're interested, then you can click on the links. And there are some really nice examples of where you have a deep learning model or something, and you train it using PyTorch, and then you pull the data into MATLAB to do further analysis, or you pull a model, you train it, you push it back, things like this, or just simply working with collaborators, right? And one of the criticisms also we get is that MATLAB is closed, right? It's a proprietary language. If somebody wants to run my code, they can't run my code. They need to have a MATLAB license. So what we are doing is we are partnering with some science gateways that are reproducible code platforms. CodeOcean is a well-known one. Wholetail is another one. These are platforms that host MATLAB. So if you have a piece of code that you want others to use and be able to reproduce, so for example, you've written a paper and you want the code of that paper to be at a place where reviewers can run it and check it, then you can upload your code onto these websites. And if you don't use these and there's another platform that you use, then let me know and I'll talk to that platform and try to do something similar. Essentially, anyone can go onto these platforms and run your code for free without a license to make sure it works. So we are also partnering actively with these sort of portals. Okay, so that's my bit. I have one request for you, which is here's a link. If you click on this link, you will go to a form. It's a feedback form for me. I'd like you to fill it out if you wouldn't mind. I have questions such as your academic status and your background with MATLAB before this course, about the MATLAB on-ramp, about this talk today, if you found it useful, too easy, too hard, if you are an owner of a MATLAB license, and you also have some free text forms to tell us if you have challenges, if you have certain things you'd like to see from MathWorks. You can click a button saying you would like to be contacted by MathWorks or not. It's absolutely up to you. But if you click on next, irrespective of whether you're contacted by us or not, irrespective of that, if you click on next, there is a second page where if you want to get a free gift from us, something small, swag, then please fill in your name and give us a shipping address, because unfortunately this is virtual, and we'll ship out the gifts to you. Okay, I don't know if there's one attendee from the US, and I think this is not going to work, unfortunately, with you. I'm going to try and talk to MathWorks US, but I'm pretty sure that things will not go through to the US via customs in this method, but I'll try to see what I can do. Okay, thank you.
Thank you, Shubo, for this very, very comprehensive. Actually, I really liked it. I learned a lot about some things in MATLAB myself. We're running a bit late, but still, it's a school. And please, if you have questions.
I see one question keeps coming up. You guys don't have access to the slides. I'm sorry about that. It's the way Microsoft OneDrive works. What I'm going to do is I'm going to put this whole slide deck onto Google Drive, and I'm going to share the link with you. I'll just send you all an email, like I did with the MATLAB instructions, with the link to the folder. Okay.
Mm-hmm. Yeah, and we can put it under in the link in the portal, because right now we have
So here's the link to the forms again. Oh, sorry, this is I'm only sending to Maria. I'm sorry. Maria, you also, of course, welcome to fill in the form.
Okay, and to get the gift. Okay.
Of course.
That's what I'm going to do.
Yes. So now it is to everyone. So there's the form, and I will upload my thing to the portal. I'll send everyone an email with the Google Drive link, and I'll share it with you, Maria.
Okay. I don't know if there are any questions. Thank you, Shubo. Thank you for the support.
Thank you very much.
Also.
Sure. And one last question. If anyone has issues with MATLAB in terms of access, in terms of help, in terms of doing something, please send me an email. I'm available. I'll show up once a day. Send me an email, and I will, if I cannot answer, I mean, we have a lot of products. I'm not an expert on everything. I will get someone at MathWorks who's an expert to answer and get them back to you.
Thank you very much.
Thank you.
I think we'll see this also connection with Python. I think Denise and Egon are following you. So we'll have a 5-minute break. Denise and Egon, we are sorry a little bit, but it's been an interesting day. I guess we are learning a lot, from that.
Thank you.
Also from us. Okay. So 5-minute break. Thank you, Shubo, and
thank you.
Bye-bye.
Bye. See you soon.
Okay, we come back at 3:05. Denise and Egon, you want to share your screen? Egon, you're here. Yes, I was looking somewhere on the other side. You want to share your screen?
Yeah, I can share my screen.
Okay, Denise, you're going to share? Okay.
Yeah. If I'm correct, everyone can see a big blue screen now?
Yes.
Yes.
Great.
A nice sky blue.
Yeah, that's the color of Maastricht University's template.
It goes well with the orange of ELIXIR, though. Okay.
Exactly. Yeah, it does. It works really nicely.
Good. So now you have, because we have added the link apparently. So I think now you have the slide. So please check also. And for the slides, Denise have uploaded.
Yeah, I just asked it in the chat, and
I see that now. Yeah. So I see.
But I hope it
Denise.
works for everyone. Yeah.
Yeah. Oh, I'm sorry. I guess I need to cut the videos now. Okay.